Hello and welcome again. So for this video, what we want to do is we want to extend our understanding of the if-else statements and the decision-making framework that we were studying in the previous video in Python, right? So let's understand that with a few more examples to just make it much more concrete. So let's create another file. Let's say elsif.py. That's a file that I created. And uh, well, first of all, to begin with, let's understand in more depth the conditional, the booleans or the true or false conditions returned by any comparison operators. So first of all, let's start with a classical example: x equals to 9 and y equals to, let's say, 12. And any comparison operator is going to return us some kind of a boolean variable, be it true or false, right? So that is what we want to investigate right now. So let's just try to print what is the let's say this is a check. We're printing the string, and what we want to do is print check if x is greater than y. So this is either going to return a true or false. As we've already studied in our previous video, this comparison operator is going to return us either a true or false. In this case, it's going to return false. So let's just run our program. So that's what it returns. It returns false, right? So let's say we could do something like an exact equality. So here also it's going to return as false because 9 is not equals to 12. But let's try something else. Let's try if 9 is less than equals to 12. So this should give us the answer as true, and it does. So right. So this true or false is going to determine which of the if or else conditions are executed, and well, one of the simplest examples of if else statements is trying to print which one of them is greater or less than. So let's just extend our example, and it's possible we could write multiple statements. Remember, it's possible for us to write multiple statements in any of the if or else blocks. It's completely up to us, but it should be at least one. There should at least be one statement. You can't just keep an empty if block. So it's going to complain. The Python interpreter is going to say that you should have at least one statement or at least one instruction over there. So in this case, we'll say that if x is greater than y, we'll say that whatever is the x. Okay, well, so, and I should remember to always separate your arguments to the print statement via a comma, right? And this is what we want to say: x is greater than y, whatever is the value of y, and that's our if statement. We are going to write our else statement. We are going to say, well, x is less than or equals to whatever is the y. So in this case, it's going to return us the second one, that is 9 is less than or equals to 12, right? So that is what it says. It says that 9 is less than or equals to 12. And the reason is because this condition turned out to be false because 9 is less than or equals to 12, and it fell back to this else clause, and it executed the line number 7, which says that 9 is less than or equals to what is it, 12, right? So we want to extend this further and accept. Now what we want to do is accept data from user. So till now what we did was we only operated the data that we defined in our Python script or Python program. But oftentimes it is not the case. Oftentimes what we want to do is allow the user to specify whatever is the input that he or she or they want to specify. And let's deal with only integer inputs for now. So the function that we want to use, or the inbuilt functionality that what we want to use to extract input from the keyboard or the user is the function called as input. That's what we want to give. And input function also accepts a prompt. It's sort of a descriptive manner of asking user to enter any specific data or any specific prompt that you might want to ask the user. So let's just say that enter first number. This is a valid prompt, and input, and we'll ask for the second number. Enter second number. Now there is one peculiar thing about the function input is that it returns a string. So what it returns is a string, right? So we want to let's say investigate what is the input returned by this input function. So what we can do is, as we've studied, there's a function called as type in the existing libraries of Python. Then what we could do is simply ask Python what is the type of x and y. The type of x, and we could also ask what is the type of. Remember, we could give multiple arguments to print function. So we are asking it simply what is the type of x and what is the type of y. For now, I'm going to comment the rest of the code, that is disable it. One way of doing it is you could select the entire code, and what comments are essentially is it's part of documentation. You don't need to. It is part of the program that is not executed. It's for our own understanding. So the way usually I comment things is I'm going to select the whole thing, and I'm going to press Ctrl and forward slash on keyboard, and it's going to enable the comment. So comment is really nothing but a piece of code that is disabled. It could be anything. It need not be just code. It could also be something like a note to any programmers, any in your team, or if you are working across teams, or even in open source communities, it becomes really important that you document your code really well. And one of the ways of doing that is writing comments. And you could simply say something like it's like a note, or it's like an explanation to whatever the code that you're writing, following the comment explains whatever is the logic behind that code. So I could write something like checking if x is less than or equal to y or greater than y, right? So this is a simple comment. It's really harmless. It's think of it just as a note to self or to any future collaborators on your code, right? So what we want to do here is to investigate the type of the variable that is returned by this input function. So it's going to return string type. So the data that's going to be returned by input is of the type string. Even if you're going to enter any numeric characters, it's still going to be a string of numeric characters. That's what it's going to be. So let's just try to execute this program. So we're going to give our first number as, let's say, 123. We're going to give the second number as, let's say, 45, and we expect both the types to be strings. That's what it is. It says that the first one is a string, the second one is a string. Now, the reason for this is that you might this is a generic function that returns a string data type by the entered data, and it's possible for us to change the type of this string, because let's say we want to work on numbers, but the input function is going to return a string, so that's not ideal, right? So what we could do is we could do something called as typecasting. So let's just quickly understand what typecasting is. Right. So let's say x equals to input, and I'm going to give some prompt saying enter a number, right? And if I say what is the type of x, it's going to say that it is a string, right? And let's say we are going to enter something like 913, so that's a number that we could enter, and it's still going to say a string and not an integer. So what we could do is, now we could do a typecast. So what a typecast really means is changing the type. So what a typecast really means is, typecast means changing the underlying type. Type of data. That we've seen different types of data, integers, floating point numbers, and strings. There's no such thing as a character. A character is only a string with length 1. And so now this is a string. This is a string. It's a string with characters 9, 1, and 3. What we want to do is we want to change it to an integer 913. So that we could operate it in a numeric, we could use numeric operations to work on this data. So what we do is simply we are going to typecast it to, let's say, we are going to reassign x, and we are going to say int. This is the function that we are going to use. The int function. It attempts to change the type of the data, but it is not always successful, and I'll let you know why it's not always successful. Or you could do something like give the input function itself, and then say whatever is the prompt that you want to say, enter a number. That's right. And so this input is going to give you a string. It's going to give you a string, and this integer is going to take this string and it is going to convert into an integer. That's how the typecasting is going to work. Or you could have also done something like this: x equals to int of x, because x here is of the string type, that is of str type. This int function is going to operate on this str and produce an integer type data, that is x. So this is how typecast is going to work. It's also possible for us to use float. If we want to use float, it's possible. It's entirely legal. You could do something like x equals to float of x, or you could just give the entire input function inside the float typecasting function itself. So that's what typecasting does. So I hope that was clear. Right. And so well, let's use a convenient method of typecasting the string to an integer, because we want to work with integers. And let's again check what is the type of x and y now. They should be integers now. So we're going to run our program once again. Run the program, and we're going to say 123 and let's say 45. It should give us class int. That's right. So this is going to give us the data type of x and y is now integer, right? So now there's one more thing that's important for us to understand, is that it is not always possible for the Python interpreter to convert any string data into integers. Let's say, for example, I'm going to enter something like let's say 35A. So this is not entirely a number. this is not entirely a decimal number because there's an alphabetic character small a in here, and which is why it's going to complain that this is not you can't typecast this to a number because it's not possible for you to create a number out of this. And let's just try that too. So let's say we're going to execute the program, and let's say 35a. Let's say 35 small a. That's right. So this is what it says: invalid literal for int with base 10. This says that you shouldn't be giving a in here because it's not possible to convert this 35 the entire thing into an integer. It's not possible for us to do that. I mean, it's obvious, right? So that is one side effect that we need to be aware of. That we need to ensure that whatever is the input that goes to the int function should be expressible and in an integer format. Right. You could also use floats here. Let's try using float, and I'll enter something like 3.14. Right. I'm going to enter 9.8. Right. So it's going to say it is of the class float, and it's going to say the class float. So for now, let's just ignore what the keyword class means. We're going to visit it in a later video. But the thing of importance to us is the data type of x and y is float data. Right. So yeah, that's about the data type and the type conversion stuff. Now what we want to do is to be able to make decisions based on the user input as we have decided to do earlier. So we're just going to remove this entire print statement, and again, this is a piece of code and this isn't a piece of code. So if I try to execute this script, it's going to complain because this is not valid Python syntax. This is a note that we have given to ourselves or to any future programmers who might want to visit what your script does. So let's just try to quickly try and run, and let's see what it says. It says that syntax error because this is not a valid Python syntax. It is only a comment that is given for our own understanding. But the rest of it is absolutely valid Python syntax, given that you've not forgotten these colons and you've written if and else constructs correctly. Right. So let's try to execute our program. You could use this extension that I've installed from Visual Studio Play Store. This is, I believe, it is. I don't know what Python should be somewhere. The official Python. Okay, my machine is not connected to the internet, but there should be some extension here called Python. Let me see. Yeah, that's right. So this is the one. It's fairly easy to install it. You could install it and it's convenient to use. So we'll just try to run a program. So it's asking for us. So for the first number, I'm going to enter 12, and the second number I'm going to say 5. Now, since 12 is greater than 5, it's going to say that 12 is greater than 5, and that is what it says. 12 is greater than 5. Right. So now this is a bit more interesting than having our own data written directly into the Python script. Now, usually in the real world applications, it's usually a mix of two, or there are other techniques of fetching the data. There are techniques where you extract data from a database, but that's a topic for different day. But the important thing is it's knowing that it's possible for us to extract data from an outside input source, and it's possible for us to again define it in our script itself. Right. So let's try a bit more interesting example. Let's say now we're trying to explicitly understand the equality relations between x and y. and we want to also understand if they are equal. So we want to segregate the greater than, less than, or the exact equality separately. In that case, we could use something like elif. So we'll say that if x is exactly equals to y, then we'll say something like, and we'll say print x, never forget the commas here, is equal to whatever is the y. And finally, you don't need to write it x is less than y, because it's implicitly understood that it will be less than y. In this case, x is less than y, right? And this program should execute just fine. So what is it saying? It's okay. There's some syntax error. Okay, so this is what I was talking about. There has to be a comma and not a full stop over there. Right. So it's going to compile, and it's going to ask us for the first number. Let's say 13. I'm going to enter the second one, and let's say 24. And it's going to say 13 is less than 24, and try to execute it again. Let's say 13, and again. So this is part of the problem, right? So this is not supposed to be an input token, which is why it is complaining. So you have to be really careful when you are entering your inputs. The second number is also 13, and it says that 13 is equal to 13. Right. The reason it said that is because 13 greater than 30 in this condition failed. If this condition failed, then you're not going to execute this print statement at line number 8. At line number 8, it's not going to be executed. Then it's going to check for the elif statement. Is 13 exactly equals to 13? And it turns out to be true, which is why it is going to execute the print statement at line number 10. And that is how it says 13 is equals to 30. We'll try one more, and let's say 9, and let's say 3. Then in this case it says that 9 is greater than 3. In the first go itself, it checks that if 9 is greater than 3, and this turns out to be true, and which is why it executes the statement at line number 8. Great. So this is a bit more about how input functions and how the type conversion works, and a more robust example on if and else statements. So now, right. Now there is something called as nested ifs. So let's understand this. For example, this is what I want to. This is my program. This is my program. Let's say I want to check if a given number, let's say my requirement is check if the given number is lies between the ranges, let's say 0 and 100, and the second range could be 101 to 200, and then it could be 201 to 300, and I want to say that okay, so I want to distinguish if my number lies between these three ranges, and or say that okay, it's greater than 300 and up to whatever is the highest possible number that is representable in Python. This is not infinity, by the way. I'm not sure if there is a concept of infinity, but I guess it shouldn't be there. It could be some abstract concept, but for most cases it's possible for us to represent infinity using the highest possible number that is representable in Python. But for our convenience sake, we'll leave it at that, and we'll say that we're not going to bother with this. and within each of these ranges I need to check if it is even or odd. I'm going to check if it is either even or odd, and for all of them. So this is what we want to do. So first of all, we want to check in which range it falls, and the second one I want to check if that within that range, if that number is either even or odd. So let's try to write a program for that. So I'm going to get rid of all this. Right. So we are going to accept the number from the user. Let's say user is going to give us. So this is what the type conversion function I'm writing beforehand, before writing the input itself. But you could use input and then you could do something like input, enter a number, and then you could do something like x equals to int of x. That is converting the string representation of x variable into the integer representation, but I find it much more easy to write it here itself. And the reason is that this input is going to give us the string value, and that string value is going to be accepted by the outer function int. So the string, once given to the integer function, is going to give you the integer representation of that variable, right? So this is what we want to ask user, enter a number, and what we want to do is we want to check. Okay, now for using checks that we've learned is the framework of decision making using if and else. So we'll say that if x is greater than or equal to 0. Now I want to check that if it is greater than 0 and less than equals to 100, both. So I need both of the statements to be true. That is x is greater than 0 to be true, and I need x is less than equals to 100 to be true, both of them. And I'm not going to forget a semicolon over here. Okay. So now in this case, what I want to do, once I've checked that it is greater than 0 or less than 100, it is greater than 0 and less than 100, I want to check if it is even or odd. Now the way that I'm going to check it is any number is even or odd is by checking the remainder of that number. Let's say something like I'm going to enter, let's say 50, and when I'm trying to divide it by 2, my quotient is going to be 25 and my remainder is going to be 0. So this is important for me, the remainder. The check that I need to do is on the remainder, whether it is 0 or it's 1, because we're dividing by 2, so remainder can only be either 0 or 1. So if I'm going to enter something like 51 divided by 2, the quotient is still going to be 25, but the remainder is going to be 1 in this case. And we studied earlier the operation that is used to determine a remainder is this one. This is the one. It's called as the modulo operation, right? And we've seen an example over here. That's what we are going to use to check if a number is even or odd. So we are going to say, let's say if x modulo 2, that is we are dividing it by 2 and checking the remainder. If that turns out to be 0, if the remainder is 0, then we know that it is an even number. And let's say it is, then we are going to say something like x lies in 0 and 100, and although you could do something much more clever here, you could say that now since x is definitely going to lie in 1 and 100, so that statement would be common for both the if and else for the modulo check. That is for the if it's odd or even, you don't need to write that print statement in each one of them. You could just write it as it's odd or it's even. You could say here, so that is you're sort of hoisting the common code between the if and else, right? So you're going to say something like x lies in 0 and 100. So this is what it is, and now since you are going to open another scope in here, it's important that you give another level of indentation. So I'm going to give another level of indentation, and I'm going to say that it is even, right? This is what I'm going to say. Now I'm done with my if part inside of the first thing. I can write else, because this if else belongs entirely inside this if, which is why it's called as nesting of if statements, or nesting of if construct is odd. The reason is because if the remainder turns out to be 0, then I know that it is even, else it's going to be odd. And we're going to do the same thing for the other ranges as well. Let's say elif. Elif is our statement to check if x is greater than 100. I could say something like greater than or equals to 101, but it's going to be one and the same thing. And x is less than equals to 200. Here I'm going to say that if it's again the same thing. So I could just copy and paste the whole thing here, or you could write it. When you're learning for the first time, it's always recommended that you write all the statements first. But yeah, it's possible that you could simply copy and paste the whole thing from here, because that logic is going to be the same. And the only thing that changes here is we're going to say x lies in 101 and 200, right? And it's going to be the same thing for elif. We're going to say x is greater than 200 and x is less than equals to 300. Again the same thing, and I'm going to say print x lies in 201 and 300, and at the end of it all we can simply write an else, because we don't have an upper range for the last condition. So this is going to be, and I could write a comment, by the way. Here you could write a comment saying that x is now higher than 300. And remember, a comment is it's not part of code, it's just for our own understanding. And I'm simply going to just copy the whole thing and paste it. And I'm going to write the prompt here saying that x is higher than 300, right? And this program should execute as per our intended use, right? So let's give a number. Let's say 4. It should say that it lies in 0 and 100, and it is even, right? So it says that it lies in 0 and 100, and it is even. The reason that it said that is because we entered 4. We typecasted it to the integer, because remember, input is going to give us a string and we're going to typecast it to an integer. Now we have integer to work with, which is why we are able to use these the mathematical relational operators here. And we're going to check the first if statement at line number 3. It's going to say that is x greater than 0, 4 is greater than 0, so this turns out to be true. And it is going to check the next condition too. Is x less than 100, that is 4 is less than 100. Since both of those conditions are true, the whole thing turns out to be true, and then you start executing the entire block. And as I said, you could write multiple statements in here, right? So then the first thing that it's going to print is 4 lies in 0 and 100, and then at line number 5 it is going to perform another check. It's going to check if 4 modulo 2, that is going to do a division operation, and it is going to check the remainder. If that remainder turns out to be 0, which it is, because 4 divided by 2, the quotient is 2 and the remainder is 0. So the remainder is 0, and we've used the equality sign to check if the remainder is 0. Once the remainder is 0, then it is going to go ahead and execute the statement at line number 6. So it's going to say that it is even. Similarly, we'll try with a different input. Let's say 9. It's going to say that 9 lies in 0 and 100. It's obvious at this point why that is the case, because this turns out to be true. And it says that 9 lies in between 0 and 100. Now it is going to check here at line number 5 if 9 modulo 2, that is 9 when divided by 2, if the remainder is 0 or 1. It is 1, because, and the reason, well, since it's 1, it's not going to execute the line number 6, because this condition turns out to be false. If this condition turns out to be false, then it is going to fall back to the else statement. In this case, it's going to say that it is on. And similarly for the other examples, let's say something like 13. It says it lies between 0 and 100, right? Yeah, lies between 0 and 100, and it's on. Let's try another one. Let's say something like 154. It's going to say it lies between 101 and 200, and it is even. Lies between 101 and 200, and it is even. Right. Let's try a few more. Let's say 450. So it's going to say that it is higher than 300. In this case, right. So 450 is higher than 300. So the way this worked is it first checked at line number 3, and this turned out to be false because x is greater than 100. Then it fell back to line number 9, and it checked that if x is greater than 100 and less than 200. So x is indeed greater than 100, but it is not less than 200. It is greater than 200, which is why this entire thing failed, because one returned out to be true and the other one returned out to be false. But the whole thing is you are doing a logical AND, which is why this returned a false statement. So it returned false, and you are going to again fall back to line number 15, elif. In this case, again, it is greater than 200, that is true, but less than 300 is not true, that is false. And the whole thing turned out to be false again. Then it is going to finally fall back to the else at line number 22, and it said that it's greater than 450, and finally checked that if 450 divided by 2, and what is the remainder. So if the remainder is 0, because 450 divided by 2, the remainder is 0 definitely, which is why it says that it is even. Right. So this is the nesting of if else statements that we looked at. Now the next thing that I wanted to do is okay. So next, what we want to do is move on to another concept that's called as functions. So now let's quickly start with the next concept for this video is functions. Right. So what is a function? We've already used functions in our code journey with Python so far, but we'll do a formal introduction for what functions are. I'm going to write what a function is. Right. So a function is nothing but it's a piece of code that is designated to a very specific task, and it is designated to do just that task. So let's say, we've all studied the mathematical functions. A function of, let's say, square root, right? The square root of 2, that is 1.41, right? Well, there are few more digits to this, but we'll keep ourselves to just the two digits after decimal. Square root of 4, that turns out to be 2. So think of function as a box. Think of it as a box that you're going to give it an input, you're going to give it an input and it's going to generate an output for you. It's going to give it an input and you're going to generate an output for you. And you could give it different inputs. So let's say if our function was square root, if a function was a square root, and if I'm going to give the input of 2, it is going to generate output of 1.41 for me. If I'm going to give the input of, let's say, 9, it's going to generate the square root, the output as 3. If I'm going to say, let's say 16, it's going to give me 4, and so on. Right. So that's what a function is. Think of it like a box. You're going to give it an input and it's going to give you an output. Right. It's not necessary that function will always give you an output. It is possible that it may not give you an output, but it's going to perform some action for you. It is also possible that it performs an action, or it returns an output. Both of these things are possible. It can give you, it can perform an action, or it's going to return an output. The famous function that we've used so far is the print function. So this print function is an inbuilt function in Python, and we simply give